Welcome to my YouTube channel Raise a Cat, and today we will see the concept of simple pendulum. Okay, so what is the concept of simple pendulum in SHM? Okay, this is the very important concept in simple harmonic motion. So we will see what and all are the concepts used in the simple pendulum for which are used in the questions. Okay, so what is simple pendulum? Simple pendulum, suppose that this is the point which is hinge, or here the thread is being fixed. Okay, this is the thread which is of length of L. Okay, and the mass M is being connected of this. Okay, and it is being moved here with velocity v. Okay, and the here it reached at an angle of theta, and this mass has reached, and this is of length L, so this is will be of length L. Okay, so the this is angle theta. So when the this will be released again, so it will reach at this mean position. This is called as the mean position, and again it will travel a distance of theta. Okay, or this distance will be r into theta, or this distance is L, so L into theta. Okay, so this L theta distance it will travel again, and it will reach at this point. So a particular, this will be there in a particular time. So what and all is the time it takes to reach from here to here will be equal to time it take from reach from here to here. So this is the concept for the simple harmonic motion. Okay, so that a time period of a particular oscillation is fixed. Okay, time is fixed of a oscillation. Okay, and that if it is not being stopped, it will keep on moving like this and this and this if it is an ideal pendulum and no resistance is there. If we take it as an ideal pendulum, it will keep on moving like this. Okay, since the particular amount of force which will be there, mg, which is here, so the component of this will be here. So it, the component of mg force which is there, will move this pendulum from here to here, and again from this this is a extreme positions, from one extreme position to another extreme position. These two are the extreme position for a particular pendulum. Okay, so from a particular one extreme position, it will be going to the another extreme position. Okay, so this is the concept for a simple pendulum. Okay, so how it is going from one place to another, now we will see. Okay, so suppose that this is the simple pendulum which is being fixed here, and this is of length L. Okay, so it is going here at an angle of theta. Okay, so the mg force is being applied here. So the this is a tension, or force F is equals to the tension force, the tension in string. This F force is called as the tension in string. Okay, and again it will move at an angle of theta. Okay, this is the force F. Okay, this is theta, so this will be theta. These are the alternate angles. Okay, so this component of this will be, one will be mg cos theta and one will be mg sin theta. Okay, so this will be theta, so this will be mg cos theta, and this will be mg sin theta. So mg sin theta, this force will give the restoring torque. Restoring torque will be provided by mg sin theta force. Okay, so mg sin theta force will give the restoring torque to this. Okay, so the what is the restoring torque? Restoring torque is F into force into perpendicular distance. Okay, restore, this is the restoring torque definition. Force into perpendicular distance. So here what is the perpendicular distance for this mg sin theta force? For this mg sin theta force, this is the 90-degree angle. So for mg sin theta force, what is the perpendicular distance? L. So what is the restoring torque? Mg L into sin theta. Okay, this is the tau restoring. Okay, so this is the restoring torque which will be there, mg L into sin theta for the this small m mass, okay, which is of the pendulum, okay. This is the restoring torque which will be there for this uh, mass, okay. So as we know, if the theta is small, we know that theta is equal to sine theta, or theta is also equal to the tan theta, or theta is equal sine theta is equals to theta. So if theta is small, so sine theta is equal to tan theta. Okay, what is the concept behind this? Since suppose that this is the perpendicular hypotenuse base, okay, this is theta. So suppose that if the theta is small, so what will happen? This theta is small, so this theta will be keep on minimizing and minimizing and minimizing. So what will be there? This hypotenuse will tend towards base if theta is small, okay. So hypotenuse is equal to base, okay. So what is this tan theta? Perpendicular upon base. This is perpendicular upon hypotenuse. So hypotenuse is equal to base, so perpendicular upon base only, so tan theta. So sine theta is equal to tan theta. So like this it will be there that sine theta is equal to tan theta, okay. So if and also if the theta is small, sine theta is also equal to theta, okay. So if theta is small, so we can write sine theta is equals to only theta. What the restoring torque was, mgl sine theta, we can write it as mgl into theta. So this is the tau restoring, okay. So this is the restoring torque which will be there, okay. So what is the definition for the torque? So this we have seen that because of this restoring torque only, the mass m is going to the mean position, and then it is also going to the another extreme position, one extreme position. Because of this restoring torque, this is going to this mean position, and again it is going to this another extreme position in a particular time period. And why is this particular time period? Because the restoring torque is always same. Here also this mg sine theta force will be there, this perpendicular distance L. So here also mgl sine theta torque will be there, same torque will be there, so same time period will be there. So as long from this we can also prove that how the time period is same for the motion, since the restoring torque is always same for the motion, okay. Is angular momentum? Angular momentum is mvr, okay. And what is torque? Torque is rate of change of angular momentum. So torque is rate of change of angular momentum, okay. So what is torque? Torque is also rate of change of angular momentum. So angular momentum is mvr, okay. Linear momentum into perpendicular distance, okay. And what is torque? Torque is force into perpendicular distance, okay. This is angular momentum mvr, and this is torque. So rate of change, so mv, rate of change of angular momentum, d by dt of mvr. So r is constant and m is constant. dv by dt is a, so ma, so f into r, okay, or f into force into perpendicular distance. Torque is rate of change of angular momentum, or it is also equals to I into omega, moment of inertia into angular velocity, okay. So these are two definitions for the torque, okay. So we know that what is the torque, or the what is the this force into perpendicular distance in this case, or the torque is mgl into theta, okay. So this is the one torque, okay. And another torque, we know that torque is also equals to moment of inertia into omega. And what is the moment of inertia? How the moment of inertia for this will be defined? So suppose that this is the particular string, okay. and this is of mass m, okay, and this string is going here of mass m, okay. So when a particular mass m is at a particular distance, so the moment of inertia is always equal to ml square, okay. So this is the moment of inertia ml square, okay. So mass m into distance square, okay. So this is the moment of inertia I. So this we have to remember that if a particular distance, so for suppose that this is of mass m and this is distance l, so moment of inertia will be ml square. So how? So suppose that this is of mass m, this is of mass 2m, and this is of mass 3m. So what will be the moment of inertia? Okay, so I from this point O. Suppose that this is point O. So I from point O. This is L. This is 2L, and this is 3L. So what will be the moment of inertia from point O? ML square plus 2M into 2L का whole square plus 3M into 3L का whole square. So this is the moment of inertia for this system. So this is how the moment of inertia for a particular system is defined. That the mass of that particle or mass of that system into perpendicular distance का whole square. Okay, so like this we will find the moment of inertia. Okay, so we know that torque is equals to torque is equals to I into alpha. Okay, means the torque is equals to rate of change of angular momentum d by dt of angular momentum. And what is this angular momentum? Angular momentum is I into omega. So d by dt of I omega is equals to I into alpha. Okay, so d omega by dt is what? Alpha. Okay, so this is what the angular momentum is. This is rate of change of angular momentum, or angular momentum is also mvr. Okay, so mvr d by dt of mvr, what it will give? Will be force into r, because dv by dt will be acceleration and m into a is force. Okay, so f into r, okay, or rate of change of angular momentum. And from this I into omega, what the torque will be coming? So torque will be I into alpha. Okay, torque angular momentum is I into omega, so d by dt of I omega is equals to I into alpha. Okay, so this is how it will be defined. So we are equating the both angular momentum and both torque. Okay, so one torque was mgl into theta. Okay, another torque is I into alpha, or ml square into alpha. Okay, so these are the two torques which are there. So ml square into alpha is equal to mgl into theta. Okay, so l into l cancel, m into m cancel, l alpha is equals to g theta. Okay, so alpha is equals to g theta by l. Okay, so this came out to be g theta by l. So this is how we will find what is the angular momentum, or the this is not the angular momentum. This is the rate of change of angular momentum, which is tau. Okay, rate of change of angular momentum. D by dt of angular momentum is torque. Okay, so now we have equated both the torque I into alpha and ml in mgl into theta. Okay, so this is the angular acceleration. Okay, and which is alpha, and omega is the angular velocity. Okay, so these are the two are the angular acceleration and the angular velocity. Okay, this we have to remember. Okay, so from this what the omega will come. Okay, or the what the alpha will be there, alpha will be equal to omega square theta. Okay, so omega square theta, now we what we found from the alpha, g theta by l. Okay, so theta and theta will be cancelled, so omega is equals to under root g by l. Okay, and what is the time period? Time period is 2 pi by omega. Okay, so t is equals to 2 pi by under root g by l. So this is the time period. This is how we will find the time period.